Hi everyone, with this new YouTube video. So we have a polynomial of the third degree that you can see as following, which is x cubed plus ax squared plus b of x plus c, and we know that it has three roots, which is x1, x2, and x3. We want to find x1 squared plus 1 times x2 squared plus 1 times x3 squared plus 1, and we are actually given another two things, this b equals 7 and c minus a, as this one, is equal to 8. Try to pause the video and have a go about this problem. Assume that you pause the video. We are given that x1, x2, and x3 are roots for b of x. Then we can write the b of x as x minus the first root, then x minus the second root, then x minus the third root. So we can write this one because it's a root, then so we can factor the polynomial into the following shape. And since the leading coefficient of x cubed is 1, then we know that the leading coefficient, or the coefficient of the whole thing, should be equal to 1. After this one, what we can after this one, let's have another look of the thing that we want to find. This thing and that one looks somehow similar, except that we have here it's square, and here we have as x1. We have here as x, and we have there as 1. So let's try to rewrite it that way. That's why you can use complex numbers. So if you want to factor this one into this shape, you can first rewrite it as x plus x1 squared, then 1 plus x2 squared, then 1 plus x3 squared. And remember that a squared plus b squared is equal to a minus bi times a plus bi. This is the factoring of complex numbers. The first one, we can put it 1 minus x1 times 1 plus x1i, which doesn't look that beautiful. So how about factoring the other way around? How about just put it x1 squared plus 1, x2 squared plus 1, x3 squared plus 1. So we can factor the first one. As x1 minus I times x1 plus I. We can factor the second one, x2 minus I times x2 plus I. And we can factor the third one to x3 plus I times x2 minus I, which looks promising. However, we want x1 to be negative, the coefficient of x1 to be negative. So this is kind of a problem. What can we do? You can multiply the whole thing by negative 1 6 times. Since you multiply negative 1 6 times, then you multiply it by 1 actually. So this thing would be I minus x1 times, and let's group x1 to get x1 and x2 and x3 together, that has a negative on it, and and negative, I mean negative I, and then we'll think that have I together, so I minus x1, I minus x2, and I minus x3 times negative I minus x1, then negative I minus x2, then negative I minus x3. Then this one and that one looks similar. The left hand side is b of I, while the right hand side is b of negative I. So that thing that we want to find is just b of I times b of negative I. Let's go and evaluate the function as b of I and b of negative I and try to multiply those things together. B of I would be, since it's xi cubed, so it's negative I minus a plus b plus c, so plus bi, and for the negative I, it will become I minus a minus b plus c. So this thing and that thing, if we can put the imaginary things together and the complex thing together before multiplying it, so just put the imaginary thing together and the real things together, because you're gonna find something amazing. And another way is like c minus a, here c minus a, and c minus a. Like okay, for God's sake, let's just put c minus a together and see what's gonna happen. The c minus a, this thing could be b minus 1 times I plus that thing, and here we have another c minus a plus, oh sorry, this I here, I fucking forgot. So we can factor another, so we can put it as b minus 1 times I and everything, because this looks way better. I mean, who want the inside different if you can put it in the same thing. So once we come and multiply those things together, we get the first one, so this thing with that one cancel. Oh, we can actually see this, it's actually the difference of the square. So c minus a on square, which is good. And with the second one, it will be plus b minus 1 all the square. C minus a, this one is beautiful. I mean, a7 minus 1 the square is 6 square. However, this one, it may not look that beautiful, but right now we will know something, that if you have the absolute value, it's the same thing as c. Remember, this square root of c square is the absolute value of that thing. So that so this thing implies that c square is the same thing as absolute value of c or the square for any number for c. Same thing for, so a, if we put c minus a as some number, then this absolute value of c minus a all the square plus absolute plus b minus 1 all the square will just happen to be equal to 100. That's the end of the video.